Hi friends, welcome to Learn QA and Allah channel. So in this lesson 1, we will try to introduce all concepts related to averages, and then we have planned another 8 lectures on this. So average lesson 2 will be having all basic questions related to this, and the average lesson 3 will have the applications of weighted average. Lesson 4 will have the complex word problems. Lesson 5 will have allegation technique. Lesson 6 will have correction model. When entering the marks, somebody entered wrong marks, how to correct the average. And lesson 7 will have when some person joined, when some persons leave, or some people are replaced, how does the average will change? That is lesson 7. And lesson 8 will have the questions on bowling average and batting average. And lesson 9 will have top 15 averages questions, must solve questions. So this is a lesson planning for average topic. So let us start the introduction part. So our idea is to make you to understand the complete information of averages. So until and unless having the strong foundation, you cannot solve the questions quickly. So if you want to apply all the shortcuts, all the applications, you must have strong foundation. So let us try to understand the concept step by step. What do you mean by average? So when we express average of 2 or more numbers, it is generally called average. So mean of the numbers as well. Arithmetic mean, average or mean, all 3 terms are same. So we will define average as sum of all observations by number of observations. Sum of numbers by number of numbers simply. So this is how we define average. Now we will denote average as A, sum of observations with the letter S, and a number of observations with the number N, with the letter N. So this is how we will express. So if you want to get sum of observations, multiply average with the number of observations. So sum of terms equal to average into number of observations. If you want to say the sum of terms, let's say the average of 20 terms is 15. Then how do you get the sum? So the sum equal to average into number of terms. So simply we can say 300. So friends, if I say what is the average of 20 numbers if the sum of numbers is, let's take 400. So these are number of terms, right? And sum of terms is given as 400. Then how do you get the average? Sum of terms by number of terms. So 400 by 20, which is 20. So all here and there the changes we can do. If you know the basic understanding, average equal to sum of observations by number of observations. Okay, let us take a simple numerical. Now you have some numbers. What is the average of these numbers? So what is our definition says? Our definition says average equal to sum of terms by number of terms. How many number of numbers are there? So you have 1, 2, 3, 4, 5, 6. So the number of terms are 6. So denominator is 6. What is the numerator? The sum of all the terms. So 10 plus 15, 25. 25 plus 45 is 70. And this is 20 plus 24, 44. So the sum is 114. And this 18 if you add, so 114 plus 18 is 132. Friends, the sum of all the terms is 132 and number of terms is 6. So average equal to sum of terms by number of terms. So this is 6 2s are 12. One remainder, again 6 2s are. So 6 2 is 22 times and 132. So average of all the terms is 22. So this is a basic understanding with this. Okay, this is called simple mean, friends. This is called simple mean. What do you mean by simple mean? If each number appears only one time. If each number in a list appears for only one time, that is called simple mean. Here see, 10 comes for only one time, 15 one time, 20 one time. So every term appears for only one time, that is said to be simple mean. But some of the times, number of numbers will repeat. What do you mean by that? So that concept is called weighted average. What do you mean by weighted average? If in the given observations, if there is a repetition of terms, that is called frequency. If there is repeated frequency for the numbers, that is said to be weighted average. Okay. Now let us consider a simple list, a set S with x1, x2, x3, and so on. Xn are the averages for the frequencies of f1, f2, f3, and so on, Fn. So guys, here x1 is one observation which comes for f1 times, x2 is second observation which comes for f2 times, x3 is third observation which comes for 3 times, and so on. I'll take a numerical example also, nothing to worry. Now our elements, our basic understanding with average says that sum of all the terms by number of terms. So here number of terms means sum of all the frequencies, that is f1 plus f2 plus f3 plus and so on fn. But the numerator, you must mention the sum of all the terms. How do you get sum, guys? We discussed sum of terms equal to average into number of terms. So here average means the elements with the frequencies, that is x1 f1 and x2 f2, x3 f3 and so on xn fn. If I denote the sigma notation, so I want to discuss it in clear discussion, because in some of the times they will give some elements like this and they will ask which of the following will represent the weighted average in terms of variable. So I just want to give you a clear cut idea. Let's see. If you notate sigma notation, sigma stands for summation. So xi fi. For example, if I say I equal to 1 to n, if I place I equal to 1, x1 f1, sigma is there, right? Plus. If I place I equal to 2, x2 f2, and sigma I equal to 3, x3 f3 and so on. So this basically sigma xi fi represents the sum of all the terms, numerator. Now friends, what is the denominator? f1 plus f2 plus f3 and so on, right? So that is sigma I equal to 1 to n fi. Fi means f1 plus f2 plus f3 plus and so on. So this is one standard notations to represent average. So please be careful. In SSC, this kind of questions may come more frequently, right? Okay, let us try to understand by taking a simple numerical, friend. If I say 10 comes for, let's say this is observation and this is the frequency. Frequency means the number of times it comes. Okay, if you want to get more clear cut idea, so let us take a simple observation, then we will come to this. So what we can do is, let us say you have a set S with the elements 5, 5, 10, 10, 10, 20, 20, 20. So this is a set. So instead of taking 5 plus and so on, the simplest way is 5 comes for 2 times, 10 comes for 3 times, and 20 comes for 3 times in the set. This is called xi and this is called fi. So x1 f1, 5 2s are 10, 10 3s are 30, and 23 is 60. So this is sum of all by number of terms, 2 plus 3 5, 5 plus 3 8. So this is 10 plus 30 40, 40 plus 60 100, 100 by 8. So 50 by 2 12.5. So 50 by 4, right? So 25 by 2 12.5. So this is the basic observation with weighted average, friends. So weighted average means sum of all the observations by number of observations. Definition is same, but to apply that weighted concept, we will multiply the observation with the respective frequencies. Hope it is very clear. So we can better understand when you go for questions. So this is a basic understanding with the concept of weighted average. Now let us see some properties of arithmetic mean. So generally many people will think that average is only sum of terms by number of terms. But if you want to excel in a competitive exams, properties is very important. With that, you can make so many shortcut guys. So quickest approaches comes with better understanding in concept. Let's see this. The first property is, if the elements of the set, if the numbers of the set are in arithmetic progression, then the average is middle term or first term plus last term by 2. So what I mean by this is, for example, if I have 10, 20, 30, 40, 50, 60, 70. Now let us observe whether these elements are having constant differences or not. If there exist constant differences between the terms, then they are said to be in arithmetic progression. So friends, here difference is 10, 10, 10, 10, 10, 10. So all differences are equal, which means they are in arithmetic progression. In such cases, average equal to middle term or first term plus last term by 2. Here, what is middle term? How many terms are here? 1, 2, 3, 4, 5, 6, 7 terms are there. So the middle term is 40. So simply average is 40. So without using that sum of terms by number of terms, you can simply get if they are in AP in arithmetic progression. You can take middle term or first term plus last term by 2 of that sequence. So first term is 10, last term is 70. So 10 plus 70 by 2, so 80 by 2, 40. So even that is also the same. There is one important property which comes many times in SSC exam, that is the sum of deviations taken from arithmetic mean is always 0. So let me write the property, then we will discuss what it is about. The sum of deviations taken from arithmetic mean, taken from M, is always 0. So what do you mean by this, right? Let us try to understand this by taking the numerical example. So friends, here we have taken example, right? So let us take the same. So 10, 20, 30, 40, 50, 60, 70. These are the elements, right? And what is the average we got? We got the average as of 40. So if I take the deviations means differences between the elements of the set and its average. So friends, in the first, the difference is how much? First term difference, first term deviated by minus 30, right? So that means the element is 30 less than the average. What is second observation? Here, the second observation is 20 less than the mean, right? So this is minus 20. I can say deviation is minus 20. So here, what is the deviation? It is minus 10, right? What is the fourth deviation? Is it 0? There is no difference. Here, the set 50 is 10 more than average. Here, 60 is 20 more than average. So 70 is 30 more than average. So these are all called deviations. So deviations means differences between elements and average. If I take the sum of all such deviations, that is equal to 0. That is the property says. So let us try to see whether the concept will work it out now. So what is sum of all negative deviations? It is minus 60, right? What is sum of all positive deviations? It is plus 60. What is sum of the deviations? What is minus 60 plus 60? 0. That is what the property says. So this question has come many times in SSC and some of bank exams as well. Please remember this. And better to represent in variable form. Actually, they will mention in variable form, guys. So what do you mean by these deviations? If I say the elements are x1, x2, x3, and so on, xn, the average as x bar, then we are taking x1 minus x bar and x2 minus x bar, and then x3 minus x bar, x4 minus x bar, and so on, right? Now let us take summation of all. So sigma, can I represent x1, x2, x3, and so on as xi minus x bar, and I is beginning from 1 and to last term n. So sigma I equal to 1 to n, sigma xi minus x bar is 0. So this is the property that the sum of the deviations taken from arithmetic mean is always 0. So understood? So this question has come many times. So please try to understand this. What is the property? The sum of deviations taken from arithmetic mean is always 0. It not only work out when the elements are in AP, it can work out for any numbers. You can check any random number. So that is the basic definition of average, guys. So middle term means the mean value. So to exist average, the sum of deviation should be always 0. Okay. So this is the first property, and this is the second property. Now let us go for third property. What do you mean by change of origin and change of scale? The very important property of arithmetic mean is the arithmetic mean affects with change of origin and change of scale. Friends, change of origin means if I add or subtract something, that is called change of origin. Or change of scale means if I multiply or divide by something, that is said to be change of scale. Now let us try to understand in a better perspective by taking a simple numerical. So let us say you have a set S with elements. You have a set S with elements. Let me mention neatly. So set S with elements 10, 20, 30, 40, and 50. Friends, what is average of this set? Can you observe? They are in AP, right? So difference is 10, 10, 10, 10, 10. So simply middle term is average. So 30 is average. Now I am going to change the origin. I am going to make some changes to this. Let's see how does the average will change. When I add 10 for every element of the set. So for every elements of set S, we are adding 10. So now 10 plus 10, 20, 20 plus 10, 30, 30 plus 10, 40, 50, and then 60. So when we make some change, when I add 10 for every element, what is average now? Is 40 average, middle term is average, right? So, okay, let us go with few more observations, then we'll conclude the topic. So let us subtract 10 from every element. Now what will happen? So 10, we have to change the elements for the original set, yes only. So 10 minus 10, 0, 20 minus 10, 10, 30 minus 10, 20, 40 minus 10, 30, 50 minus 10, 40. So we are making changes for this set, guys. Now when I subtract 10, what is the average now? Is 20 average. So the new average is 20. Now let us talk about change of scale. These two are called change of origin, guys. Let us go for change of scale. Let us multiply every element of the set by 2. Then let's see what will happen. So 10 into 2, 20. 20 into 2, 40. 30 into 2, 60. 80, and then 100. So what is average now? So the average is middle term, that is 60. Now let us divide every element by something. So let's talk about the division case now. If I divide every element of set with number 2, let's see what will happen. So 10 by 2 is 5, 20 by 2, 10, 30 by 2, 15, 40 by 2, 20, 50 by 2, 25. So friends, what is average now? So average is middle term, 15. Now the observation, the conclusion is that in whatever the proportion that I changes to the elements of the set, in the same proportion, the elements also changes, right? So here, when I add 10 for every element, average increased by 10. When I subtract 10 for every element, average also subtracted by 10. When I multiply every element of CTS with 2, then average also multiplied by 2. When I divide every element by 2, then average also divided by 2. So this is called change of origin and change of scale. So this property plays a very crucial role in most of averages questions, so that you can understand when we actually start doing the numericals. So this is introduction class where we try to give you the complete picture of averages concept, right? Is it clear? So the conclusion for this property is in whatever the proportion you changes, you do the changes to the elements, the same proportion averages also changes. If I increase every element by 20%, then average also increases by 20%. That's all. So let us continue to the next property. So this property we discussed, guys, sum of deviation from aim is always 0, right? Okay. Now let us see some of the very important applications with numbers. What is the average of n consecutive natural numbers starting with 1? So that means you have consecutive numbers 1 plus 2 plus 3 plus and so on. N numbers are there. What is average of all such numbers? Friends, what is sum of n consecutive natural numbers? That is n into n plus 1 by 2. What is sum of n consecutive numbers? N into n plus 1 by 2. Now average means sum of terms by number of terms. So sum of terms means sum of all these elements, that is n into n plus 1 by 2. And the number of terms are 1 to n. So n gets cancelled. So this is n plus 1 by 2. This is nothing new. This is a property that we discussed. When the elements are in AP, when there exist constant differences between the numbers, then average is first term plus last term by 2. So first term is 1, last term is n, n plus 1 by 2, right? Okay. Next property. What if sum of squares of n natural numbers is there? I mean, if you ask what is the average of 1 square plus 2 square plus 3 square plus and so on n square. Sometimes he may not start with 1 square. Sometimes in between, what is the average of 10 square plus 11 square plus 12 square plus and so on 25 square. In such cases, we need to make some changes to the set. That we'll discuss in solving the questions. So as of now, let us see the application. What is sum of squares of n natural numbers? N into n plus 1 into 2n plus 1 by 6. This is sum, right? Then what is the definition of average? Average definition is sum of all the terms by number of terms. The number of terms are n only, 1 to n numbers are there. Now what is the sum? This is n into n plus 1 into 2n plus 1 by 6. Friends, here n gets cancelled, then average equal to n plus 1 into 2n plus 1 by 6. So this is the average for sum of squares of n natural numbers. What if it is for sum of cubes of n natural numbers? We don't ask you to by heart. We are just asking you to understand what it is. What is the process behind finding the average? Now, we know that sum of cubes of n natural numbers is, how do you get sum of cubes of n natural numbers? 1 cube plus 2 cube plus and so on, n cube if it is there. Then sum equal to n into n plus 1 by 2 whole square. This is a square of sum of n natural numbers. So when you divide this as n square into n plus 1 whole square by 2 square is 4. So this is sum. Then how do you get average? So average A equal to sum of terms, that is n square into n plus 1 whole square by 4 by number of terms are n only. So 1 to n terms are there, right? So n gets cancelled. This becomes n into n plus 1 whole square by 4. So this is sum of cubes of, average of sum of cubes of numbers. Now let us discuss few more properties. What is the average of first n consecutive even natural numbers? So we strongly recommend you to think about numbers, don't by heart. If I have numbers like 2, 4, 6, if I ask you what is the average of 2, 4, 6? So let us go by traditional method, then I'll tell you the process behind it. So 2 plus 4, 6, 6 plus 6, 12. So 12 by number of terms are 3, so average is 4. Okay, if I have 2 plus 4 plus 6 plus 8, what is average now? Average equal to 10 plus 10, 20 by number of numbers are 4, so average is 5. So what is the generation here? So when I add 1 to the number of elements, here 3 terms are there, so plus 1 is average. Here 4 terms are there, plus 1 is average. So similarly, if there are n natural numbers, n natural even numbers, then average is n plus 1. Then the average is n plus 1. It is quite simple, guys. If I take 2 plus 4 plus 6 plus 8, if I take 2 common, you get 1 plus 2 plus 3 plus 4, right? I'm just trying to give the derivation. 2 into, what is sum of terms? N into n plus 1 by number of terms are n, right? So n and 2 gets cancelled, so you'll get n plus 1. So that is the process behind it actually. Okay, we are not asking you to by heart, guys. We are asking you to understand the process behind this. So try to understand our motto of learning. What is the average of first n consecutive odd natural numbers? For example, if I say 1, 3, 5. What is the average? Middle term, 3. So is it nothing but the number of terms? N only, right? If I have 1, 3, 5, 7, 9, then what is average? 5. How do you get this? Number of terms, 1 plus 2 plus 3 plus 4 plus 5 terms are there, right? So if there are n odd numbers, then average is n only. Simply, number of terms will be the average for consecutive odd numbers. Okay, now let us try to understand what is the way of expressing for weighted average in terms of application manner. If the average of n1 numbers is a1 and the average of n2 numbers is a2, then the average of total numbers n1 and n2 together is what? Friends, we discussed in the second application, weighted average, that is x1, f1, so n1, a1, f2, x2, that is n2, a2 by sum of all the numbers, n1 plus n2. So this is the way of expression. So sometimes they may ask you, the average marks of 20 boys is 30 and 30 girls average is 40, then what is average of all students? So in such cases, we can use this effectively, right? So let us continue. Okay, now we have the concept of average in terms of time and distance as well. That is called average speed. Now let us try to understand this situation, guys. If A goes from P to Q, so let us mention the points as P and Q. So the person A is moving from P to Q at the speed of x kilometers per hour, and coming back and return from Q to P at the speed of y kilometers per hour, at the rate of y kilometers per hour. Then what is the average speed of the total journey? So friends, we will define average speed as total distance traveled to total time taken. Total distance traveled to total time taken. So you can apply this whether if the body is traveled equal distances or unequal distances. So the clear-cut idea have been clearly discussed in time and distance video. So as of now, for this, we will try to understand the concept of average speed in detail. So the definition says average speed equal to total distance by total time taken. So what is average speed? Total distance by total time taken, right? So when a person travels from P to Q and Q to P, he travels equal distances. In such cases, we will given 2 first speed, second speed by first speed plus second speed. So that is 2xy by x plus y. If you want to have the derivation, let's see. If I take the distance is d, now average speed equal to total distance in the journey, P to Q d kilometers and then Q to P d kilometers. Totally he traveled 2d kilometers. And then total time taken. So time taken from P to Q plus time taken from Q to P. So time is distance by speed, right? So distance is d, speed from P to Q is x. And similarly, time taken from Q to P, distance by the speed is y. Now d gets cancelled. So this is 2 by 1 by x plus 1 by y. If I take LCM, 2 by xy is LCM. So this is y and this is x, cross multiplying y plus x. So guys, if xy comes to numerator, that is 2xy by x plus y. So you can use this similar way of expression for unequal distances as well. So that's the reason I discussed the derivation as well. Okay. Next property. So always remember, when the body travels equal distances, average speed is 2xy by x plus y, or 2 into first speed into second speed by first speed plus second speed. Now, there is very important model, that is average of a bowler. So we will define this as the total runs taken to the total number of wickets. For example, a bowler given 200 runs, let's say for 15 wickets. So he has taken, for example, in a test match, you will have 2 innings, right? So in 2 innings together, he given 200 runs and he has taken 15 wickets. Then we can say average of bowler equal to total runs scored by total wickets taken. So these details we clearly discussed in average lesson 8, where we discussed elaborately about different ways of framing bowling average, batting average kind of questions, right? So this is one simple class where we would like to show you all the applications for average concept. So that's all we have planned. So thank you so much for watching this video. I hope we given all properties related to average. Now don't miss out having average lesson 2, where we discussed weighted average. So thank you so much. If you want to get more such updates about our learning process, you can subscribe to Learn QA and Allah channel and click on the bell icon to get all the notifications. Keep learning, keep inspiring friends, and the best wishes for all your competitive exams. Thanks again.